29. All right, I don't know. Watch your mouth. Gasolina, gasolina, that's what it makes me think of. All right, so this is what I put down. This was supposed to be 39. That was my bad. It was supposed to be 39. If you did 29, I'm okay with it. That was my mistake. I said 39. I know I did. Okay, so checking the homework. If you're traveling or absent, check it with me when you get back, because I'm not going to post a video of it. So I haven't made a single mistake today, which is pretty cool. We are going to look at two of the problems from the assignment, or the supposed to be problems from the assignment at least. This was supposed to be a wonderful 3-9. Okay, I don't care if we do 39 or 41. Did everybody do 41? Okay, we'll check, and I want you to tell me if we do something similar. On 39, we are trying to find a unit vector, which means it has a length of what? 1. Okay, so we are given on 39, this is silly. 39 is so easy. We're gonna do 41 as well, just so you know. We're given a vector u, and I'm gonna name it v because that drives me crazy. We're gonna have a vector v, and I am told that it is the vector in component form 3, 0. Okay, I'm trying to find a unit vector that goes in the exact same direction as this. This is super easy for a particular reason. Can you tell me the magnitude of this? It's 3, like immediately, right? It's 3 long. It's just horizontal. So if we want to show all the math, what we talked about yesterday is this is a vector of length 3. I need to scale it down by 1/3 to get a unit vector. So the way that that looks as ugly math, it looks like this. 1 over the magnitude of v times v. I don't need that. V. And this is pretty straightforward. The magnitude is 3, so it's 1/3 times this guy. And what do we get as a unit vector in the same direction? 1, 0. I think we should maybe do 41 together too, because it's a little more interesting. Okay, before we move on with just the basic one, did this feel okay? Just what I just did, like, it feels easy when we do it, I imagine, especially together. Conceptually, are you cool with what just happened? Length of 3, take 1/3 of it, and now we have a length of 1. Okay, 41 is a little bit more interesting. We had the vector on 41. We were dealing with the vector -2, 2. And we want something in the same direction, but a length of 1. So, right off the bat, could we find the magnitude of this vector? 2 squared is 4, plus 2 squared is 4 more. That gets us to 8, and the square root of 8, right? Okay, I'm just going to jot this down here. The magnitude of vector v currently is the square root of -2 in parentheses, squared plus 2 squared. And if you don't need to have all this work shown, that's okay. I'm going to call this root 8, but I'm going to go one step further. How do I get to 8? 4 times 2, right? Why would I care that it's 4 times 2? Oh, I know the square root of 4. It's 2. Are you guys okay with saying the magnitude is 2 root 2? And we're going off of memory here, because if you did 31 or 41, did you get this as the magnitude? You may not recall. Okay, that's okay. Now check it out. It's an ugly number. Right now it's easy to say, I have something that's 2 root 2 long, and I need it to become 1 unit long. What do I divide it by? Or scale it by, if you will. Let me 1 over 2 root 2. So check it out. If we want this unit vector, u is how I name these, in that direction, we're going to use 1 over the magnitude, which is 1 over 2 root 2, times our original vector. This is going to scale me down. That's all that's going to happen. So let's just see, when I distribute in, I'm going to take 2 steps here just to make sure we can see the math. It is -2 over 2 root 2, comma, 2 over 2 root 2. Questions, concerns, compliments? Ouch. Okay, anything obvious left to do? So the radical parts maybe, but even before I think about the radicals, what is 2 divided by 2? Those are gone, right? So here's where we wind up, and anybody who wasn't here yesterday, important update with just class stuff. At this point in time, I'm okay with this. Now, here's the issue, and I imagine you'll be able to appreciate it all the same. Can you tell me where exactly on the unit circle this is? Probably not just by sight, but if we rationalize and call it root 2 over 2, does it now seem like it's a place on the unit circle? Root 2 over 2 over, and root 2 over, like that shows up 4 places, right? It's just plus or minus. So there is a value to changing them, because they show up much nicer in that form. Okay, now, as a little tiny extension, I now have a vector in front of me that has a length or a magnitude of what? It has a magnitude of 1. If I wanted to hypothetically, and this is going to be an ears open, I think we're going to try to not just do a problem like this. If I said find me a vector v, or a new vector in the direction of v with a magnitude of 5, could we do it? And we're actually going to jump right in with this problem immediately. I want you to prove it. Before we move on, questions, issues, anything you want to talk about further before I introduce a very related but a little bit different looking problem. All right, so I will clear that out, and you guys are going to try one problem that we've never talked about directly, but I want a conceptual understanding of it. So one more example dealing with these unit vectors and maybe where they can help out. I want us to find a vector, and I'm just going to say, instead of saying a vector, I'm going to say find vector v in the direction of, let's call it vector, I don't know, q. And Sean, what's your favorite vector? This was a terrible mistake yesterday. Terrible choice. Okay, I like that one. Negative 3, 5 sounds good, Sean. I don't know why I already asked. I'm sorry. Okay, I want us to find a vector v in the direction of this one with the magnitude of vector v equal to, I don't know, 7. So, I want us to conceptually think out what's going on. And you don't have to draw it, but we're going to think about it. Okay, right now, if I were to sketch this, and again, you do not need to, I'm just going to get a coordinate plane. Vector q, I'm trying to use that direction. It goes to negative 3, 5. It ends up somewhere like this. This is vector q. Are you guys okay with this? Right now, knowing that it goes to negative 3 and 5, can you guys tell me, without doing any additional work, the length of this vector? So I see you doing work in your head already. Is it obvious right now the length of it? You could find it, right? You could Pythagorean theorem, you could do it, but it's not super clear. It's not 4, because 3, 4, 5 is a right triangle, and the hypotenuse would have to be 5. Bummer. So it's 3, 5 are Pythagorean numbers. Anyway, as we're looking at it, whatever that number is, does there exist a number that I can multiply it by to get to 7? Now, that's kind of hard to do, but check this out. Do we have a way, any way, that we could take this vector q, and I'm going to erase it, I'll just change color. Could I take vector q and take it from this length and give it a length of 1 instead? Could I shrink this thing down somehow? That is me changing it into a what vector? A unit. So if I had a length of 6, I just multiply by 1/6, right? Now, what would I multiply? If I do this, what would I multiply by to get it to be a length of 7? I went from ugly numbers down to 1, and now I just times 7 again, right? So check this out. And I lied. I said I was going to make you guys do this, but here we are. Okay. If I start with vector q, I know that I can make, and I'm going to do one big trip. This is one line of work, but I want to make sure that we have it. If I take 1 over the magnitude of q, and I multiply it times vector q, what does this produce? Not like numerically, just conceptually, what is this thing? It is my unit vector. And then just a second ago, now that it has a length of 1 and I don't have any numbers, what do we multiply it by to give it a length of 7 instead? 7. Now check it out, because this can be really misleading. Could I do this and find some ugly vector and then do 7 times some ugly vector right here? Could that work? Alternatively, could I multiply it by 7, another scalar right here if I so decided? Would it look a little bit nicer still if we just simply make this a 7? Am I still dividing it by the magnitude of q to get it to be a length of 1 and then multiplying it by 7? Is this the same operation in the end? I think so, and I can't tell if that clicked or not. Okay, so I'll take little trips. This thing is a unit vector, right? This has a magnitude equal to 1. Is everybody okay with that first step? So I'm just gonna, I don't have a nice way to write this. This is a new vector with magnitude 1. Cool with that. What do I multiply this new vector with a magnitude of 1 by so that it becomes a length of 7 again? To make it a length of 7, I would just take 7 times, and I'm so sorry about the ugly notation stuff here, but this is the way that we've written out that vector. This is now 7 times the unit vector. Everybody cool with that? Do you agree that it maybe, just maybe, it would have been easier from the get-go to just do it in one step? We'll divide it by this magnitude to give it a length of 1, and then we multiply it by 7. Like, would that just be a one-step process through this whole thing? Take it, shrink it to a length of 1, and then blow it up to the length that you need. But we can do it in a single step. So, at this point, I want you guys to get me this actual vector. It's 7 over the magnitude of q times vector q. And that's how we get our new vector in the direction with that length. I will give you a moment. As we come back together, this process will wind up being super handy. Not, like I hate to say it, we're going to use things like this when we look at the 5th section, but realistically, anybody who ever becomes an engineer or has to take a class called linear algebra while you're doing these sorts of things, this is going to show up all over the place. Okay, this process feels okay, feels awful. Should we do one more? Okay, and by that, I mean I want you guys to talk through it. I want to actually hear it. Before we do, is there any questions about what I've done? The next one will have so much less writing. Okay, so let's try one more, and I might try out put this on your desk and let you write on the board for it. We'll see. Okay, on B, I want a vector v in the direction of, let's call it, I don't know, t, where I'm going to throw you guys for a loop here. You will not see this in your text right now, but this is a normal way to write vectors, right, with these guys. Okay, turns out, similar idea. I'll write it twice here. Let's say we get vector is -2, 4. And just so you're aware, if you happen to like be, reading about linear algebra stuff in your spare time, I'm sure that's what you do, maybe, just maybe, you will see this vector written like this instead. Which feels like we're in the matrix at this point. They are certainly things. You can write vectors in matrices. We do this, we're just not doing it right now. Okay, be in the direction of t with a length of, I don't know, with magnitude of v. Let's get real crazy. I want it to be pi. Cool. I'll give you a cool cats and kittens moment. If we can get to here, the rest of the problem is super easy. If I took this expression, 1 over 2 root 5, and then I multiplied it by this vector, this thing will now have a length of what? So you're trying to give me the coordinates, right? -2 over 2 root 5, but that's not what I'm after. I just scaled this down by its length. I divided it by how long it was. How long is it now? Anything divided by itself. This has a length of 1. This, this is my unit vector. This is the first part of the problem. Now, I did it in one step earlier. Sean, you seem like you might disagree. Okay, this is 1 over the magnitude of t times t. So if it were 5 long, I just multiplied it by 1/5, and now it's 1 long. But it was 2 root 5 long, so I multiplied it by 1 over 2 root 5, and now it's 1 long still. What do I want it to be? So let's just take this and multiply it by pi now. So if I did this, I could, and it's correct. Is there a more concise way we could write it though? Yeah, let's just put that pi in the numerator, and I'm actually, since I wrote it, I'll do it. This is going to now scale it up to be a length of pi, and check it out. All we have to do is distribute this lovely thing in here. So here we go. Finally, we end with our fantastic vector v, which is negative 2 pi, and that's going to drive me crazy. So I'm just going to call it negative pi over root 5, and 2 over root 5. What did I skip? The simplification. I saw 2 over 2 root 5, and I just divided it up. I forgot something. Gosh darn it. There's a pi here. Cool. Ugly number, but the process is all the same. Scale it down, scale it up. 2 steps. Okay. Now, I don't want this to become a linear algebra class. Questions? Please ask if you have. Hit it. The 4. 4 pi. So when I put the pi in, I do this. And 4 over 2 is 2. Yep, cool. All right, so we are going to do a little tiny continuation from yesterday's stuff in our notes. We have a couple more examples here. We have a lovely vector of the given length in the right direction. Today, we're going to go a little bit further in unit vectors. Now, it turns out that within unit vectors, and if I go too fast, please tell me, there are a couple that we use as what are known as the standard unit vectors. So, with this, there is a lot of math theory that can go into this. Standard unit vectors. Okay. I don't know, because I'm not going to do it exactly like I did. I know that mine take up like this much space on my page. You're good. Okay. Now, just so you know, if you wind up pursuing math further, you may see this referred to instead as our basis vectors. Okay, standard unit vectors. These standard unit vectors can be used in some combination of scaling them and then adding them to get every number in our coordinate system, which means every possible vector that could show up will show up as a combination of 2 vectors if we're in 2-dimensional space. How many vectors if we're in 3-dimensional space do you think we need? 3, you got it. We're going to go crazy. What about 5-dimensional space? I don't even know what that looks like, but I know what the vector needs. 5 pieces. Cool. So, looking at these, there's only 2 true directions that we need in our 2 dimensions. What are the 2 directions that everything's made of? My components, we might call them. We have x and y, right? So, check it out. We have 2 vectors. We have the first one, which is I. This is one of the 2 standard unit vectors in 2 dimensions, and it is the x direction. If I asked you to give me a standard unit vector, it has to start at 0. How far to the right do you think it goes if it's a unit vector? I'm backward. How far to the right does it go? I'm sorry, you're going to see why it is here in a second. 1. How far up should it go if I wanted to have a length of 1? Good. Check it out. Here is the vector I, which you likely won't encounter it, but alternative notation for these, because it gets ugly, I hat is pretty common to refer to this. With that little triangle thing above it instead of this. I like this. Okay, this knocks out the whole x direction. Any place in the x's I can get to from scaling this vector. What's the other direction I need? The y direction. So we have vector j as our y unit vector, and it's 0, 1. If we were in 3 dimension, I would add vector k, and we would just have 1, 0, 0, 0, 1, 0, and 0, 0, 1. And all of a sudden it feels like it's the identity matrix, if you remember all the way back to doing those things. Okay, for this, your book goes a heck of a lot further than I think we need to. And it doesn't happen very often, but we're going to make a couple little comments. Every vector, every single vector that you will ever encounter, whether it's real or imaginary, can be written as, and I'm going to let you guys catch up before we get this. Every single vector ever can be written as what is called a linear combination. A linear combination of, and I'm going to use the term basis vectors because it is shorter to write. Okay. Now, we are not going to see the big, all-encompassing reason why this is so important, but we're going to see that it's really easy to do. And I'm not going to generalize it. We're just going to say, check it out, and I think you guys are going to be able to tell me what's happening. So here we go. Let's say that I have a vector. Now, this is kind of an example, but it's like an EX or EG as well. So let's consider the vector that we'll just call it V as, I don't know, we'll call it A, comma, B. It is some vector that exists. Don't care what it is, there it is. If I wanted to, can you tell me how far in the x direction does that vector go? It goes A in the x direction. Now, what we can do, and you probably, again, let me know if you can tell me what's happened. If I just take A and I make it a scalar, and I multiplied it by this, do I get the same thing? I'll now just have a vector that's in the direction of this I vector, right, my basis vector, but it goes A over instead, just like this one does. Okay, I could add to this B, and that goes in the Y direction, and if I use the basis vector there, it would just be this. Now, for our purposes, I just want to really express this is just a different way to write our vectors for us. There's bigger implications to this thing that we don't care about right now. It's just a different way to write the vectors. It'll show up all over your book. If we go one step further, on the screen right now, I've told you what this is. 1, 0 is the basis vector in the x direction, and we call it what? It is, and what's the letter of this one? That's AI, hat, plus B, some scalar, times J hat. And I might like the hat notation. I don't know, I can't decide. What do you guys, you like the hat?
I like that.
Okay, cool. These are interchangeable. Okay, every single vector can be written like this. Now, again, we don't get to see the implications of this in here. If you're interested, I have a YouTube channel for you, 3 blue, 1 brown. You should look this up. It might be 3 brown, 1 blue. I get them mixed up. It'll show up. Basis. If you are looking for something to get you tired in the evening and TikTok isn't doing it, this also won't do it because this stuff is. Okay. It is it 3 brown? It's going to drive me crazy. It's going to be blue and brown. I always get it mixed up. Always. Ah, it is 3 blue, 1 brown. All right, cool. So, his channel's fantastic. This is that 16-part series of linear algebra that, oh, it's exhilarating. Okay, as we look at these, they exist. I just want to highlight here, when you're dealing with stuff in the assignment, whether it's tonight or tomorrow, and you might have noticed it last night and thought, what the heck is going on? Check it. Holy cow, I's and J's everywhere because they're just expressing it. Just to see it real quick, if I wanted us to write this vector not as a linear combination, what's the coefficient here on I? 1, and what's the coefficient on J? This is vector 1, 1. Sorry, 1, 1. Okay, this vector right here, give it to me in component form. 7, -3. But remember, 7, negative 3. Okay,